Hello, I'm gonna talk about the experiment that we did in our last digital design lab. Yes, in this experiment, we designed and tested a combinational digital logic circuit using basic logic, gates, and integrated circuits in order to understand how Boolean expressions are implemented in real hardware. The main objective of the experiment was to create a logic function, verify its truth table, and observe how the output changes depending on different input combinations. First, we designed the circuit in the simulation software using three inputs, which are labeled as A, B, and C, and one output labeled Y, as we can see in the picture right here, A, B, and C, and output is Y. The circuit combines an XOR gate and an AND gate. Inputs B and C are connected to the XOR gate, and the result of that comparison is then connected to an AND gate together with input A. This means the output becomes logic 1 only when input A is equal to 1 and inputs B and C are different from each other. We then verified the circuit by creating and analyzing the truth table. From the truth table results, the output Y was equal to 1 only for the combinations 101 and 110, while all other combinations produced an output of 0. This confirmed that the circuit was operating correctly. After completing the simulation, we implemented the same design. The inputs were connected using colored jumpers. Let me show you here. Yeah. Yeah. The inputs were connected using color jumpers. Wires where each color represented a specific signal line, and the output was monitored through the Y output terminal, VCC, and GND. Connections were also applied correctly to power the ICS. During the experiment, we tested all possible input combinations manually and compared the hardware results with the simulation and theoretical truth table. And the truth table that we have is in here, right here. We tested so many tests as we can see here, so many photos. And that's our truth table. We wrote it on a paper. Yeah. As I said, we tested all possible input combinations manually and compared the hardware results with the simulation and theoretical truth table. The practical results matched the expected outputs, exactly proving that the designed logic circuit functioned correctly both in theory and in hardware implementation. Through this experiment, I learned how Boolean algebra, truth tables, logic gates, and digital ICS are connected together in practical digital system design. We also gained experience in circuit implementation, troubleshooting wiring, connections, and verifying outputs experimentally, which helped strengthen my understanding of combinational logic, circuits, and digital electronics fundamentals. And that was our what we did in the last lab, and that's gonna be the presentation. And thank you.